and I'm also going to show you in a second how to actually completely do this from scratch. I'm going to do it on a full separate computer to make sure that all the files and systems that I've set up on here are completely blank, the exact same way you would have it when you're first doing this, because that's one of the things I hate about tutorials online, is because they assume everything is already set up on your computer, when obviously for you who's never done it before, it's not set up. So I'll walk you through how to do all of that, because it's not as straightforward as just pressing the upload button. So, it's been a bit. Waited a while for this to arrive. You're probably wondering what this is. It's the Zombieverter. This is by Damian McGuire. He has his own YouTube channel. I'll link that. This is the Zombieverter, which is the open source board. Pretty sure it's a derivative of the OpenInverter board. The same people who work on the OpenInverter board also collaborated with him on this. This supports a large range of electric motors. It supports that because it supports a lot of inverters, different chargers, mostly CAN-controlled stuff. But yeah, it supports a lot of things, including Gen 1, 2, and 3 of the Nissan Leaf. Also the Gen 2 charger, which is why I really went with the Generation 2 Nissan Leaf, because I don't know how else I would charge this thing. Since I started planning to use this board, a lot of other things are supported. Especially, I believe now they're working on getting the BMS and the Leaf battery pack supported on this well. There was originally another way I was going to do that, but they're actually integrating it into this board as well, which is super cool. By the way, there's 3 ways to buy this board. One is you go to his Patreon, you buy the files basically, or you sign up, you get the files, and then you have it manufactured for you through a manufacturing company. They probably have one in particular that they use, and then you can do all the soldering and programming the chip yourself. I don't know how much that costs, it doesn't actually say. And then there's version 2, which is 350 euros. It's paid through a PayPal, and so there's some PayPal fees and everything. I can't remember, I think this was about $417 US. It's a little bit more than that, do the conversions and fees. And then obviously you have to buy all the connector kits and everything, which you'd have to do anyway, but that's an extra 30 bucks, you know, to add to it. But there's a third option, which is the complete thing. You don't have to worry about anything. Everything's done. Everything's pre-packaged. It comes with the enclosure. It's around 750 euros. So that'll probably end up being a little bit over $800. Probably around the same price as the Resolve controller at that point, which if you're doing all Leaf components, the Resolve controller actually might be the way to go, because it's pre-done for you. Everything just works with each other. But you can't do tuning and tweaking like you can do this one, which is why I want to use this board. Additionally, there's another project I want to end up doing eventually that also uses this board, so I want to familiarize myself with it. And I might end up changing the charger out from a Leaf charger to something else. But it gives you those options that you can use other components. You're not stuck to just Leaf parts. This is also the enclosure that this is supposed to fit. Very nice. Now there are some things I'm going to have to solder on here. For one being, there is a lot of pins here, and that goes to a header that plugs in. It's missing the Wi-Fi module, because the way you interface with this is through a web interface. I don't believe that there's actually a plug-in method where you plug into this and then you can connect to that. I believe it's all wireless, which has its pros and cons, but mostly when this is set up, you're good, and then you can communicate over CAN and stuff like that to get all the other connections. But everything that's connected outside of this would be through this header. I don't know how well the Wi-Fi works through this metal box. I thought it was plastic, but it's indeed metal. Yeah, it's quite nice. And all the other things that are missing over here, he gives them this nice little extra little package, which is really nice of him. That way so you don't have to go searching for that yourself. Here is the header. These pins are right angle, so these will slot right down into there. We'll solder that on. There's 2 options, and there's one that you do all the pinning yourself. Here's all the actual pins, and you supply your own wire. This was like 30 bucks for the box, the header, the connector, the pins, and this outside gasket. Additionally, you're going to need to supply your own wire and one of these. But there's another option that's like $86 right now. It's really high for some reason. But it's basically this, and this has like 3 meters of wire connected to it. I probably should have gone with that option, but I figured it'd save the 80 bucks and only use the pins I actually need. I would like to use wire that has a grounding shield around it, so we don't have to deal with EMI a little bit, the electromagnetic interference stuff. Now, he did mention one of the videos. Apparently, it's a separate kit if you want a gasket that goes all the way around here. Yeah, that's kind of odd, but whatever. So I'll go there, let's go in there. There are 4 screws here. I imagine that's for the outside, not the inside. But yeah, that's a nice little ECU box, or VCU box. Let's open up this little package here. Let's see what we have in here. Okay, so we have a bunch of headers. We have a few things on this board. Then there is a ESP8266 module. It'll give us our Wi-Fi, identified as the Wemos module. I remember he was having issues with the original module. I guess he switched over to this one. I actually thought there was going to be more stuff I was going to have to solder on here, because originally they were out of stock of certain things and you had to go to the DigiKey. But then he said that he was giving these little packets of, you know, the extra parts, which was super nice of him. It looks like that hasn't been updated, because some of those parts that I thought I was going to have to solder on here are already on here. So yeah, so I'm going to have to see the updated version of that. Oh, I just realized there's something still in here. Oh, yikes. I don't know if you can see that. Oh, God. Where did these go? And there's two. I don't know what these are. They look to be like 4-pin little something-somethings. Oh, I have no clue where these go. If it includes them, they're for something. So it's about an hour later. I watched the most recent video on assembly and using this board, and it looks like this is the second iteration of the board, even though it's not, part number hasn't changed. It is the second version, and we know it's the second version because it has the Wemos, however you want to pronounce that. And there is a square mark on the top left corner, and usually that's a ground, or it's marked on here as well. Apparently it's not. Apparently that's the reset pin, and you have it to where the actual package is facing upwards. So step one would be putting on the headers for this guy. Wrapping up the last three here. That's all of them. A visual inspection. That is our board with the connector. Let's see how that fits into here. Screws seem to line up, but let's pretend that is screwed in for a second. Is our VCU. Pull up the wiring diagram, and I'll give this some power. Connect to it over its wireless interface. The solder cooled down quite quickly. I grabbed some alligator clips. I have not given it power yet. So let's turn on the power supply. Set it to 12 volt, and just to make sure, pretty close, 12 volts. I'm looking at the pinout diagram right now, and I can see that pins 55, which is ground, and 56 is permanent 12 volts. Pin 56 is this bottom right pin, and then one pin to the left is that ground. And there, and then we have the ACCTY, which Damien says in video 4 stands for activity. You have to connect to it over Wi-Fi, and this one's called ESP with a series of numbers behind it, 192.168.4.1. Getting an error message saying communication problem between ESP and STM. Power it down and turn it back on. Do a refresh real quick. Damien McGuire, he does a power-up test with a flashing light that's supposed to be flicker 10 times in a second. He says that he puts the bootloader on it. I assumed when it says that on the Zombieverter VCU page of the OpenVerter wiki, under software update, as supplied, both the ESP8266, the Wi-Fi plugin board, and the STM32 main MPU are preloaded. So the chip is supposed to be preloaded, yet when I access the web interface, I do not have access to the chip. Well, I'll see where I can get from here. It's been like half an hour. I'm still not getting any connection between the ESP and the STM, and I quite frankly don't know why. The only thought is going over all the solder joints. So either something is broken on this, or there's a bad solder joint somewhere. I'm just gonna get the soldering iron back out and just touch over everything. Why is there 3.3 volts on the 5 volt rail? That's what's really confusing me. There's 3.3 volts on the 3.3 volt rail. Oh, L4, L5. How did I miss that? L4 and L5 are not there, and they have the exact same trace pattern as those little tiny little baby chips. L4 and L5 are there, and they look exactly like these baby micro little chips. Okay, now we're on to something. If you have a parts bag that's around August 3rd of 2024, oh, flipped, maybe that's March 8th of 2024. Anyway, if it says 2024 08 03 on yours, or somewhere around there, and you have two tiny little chips, it's L4, L5. So if you ever need to know if you have a weird part and it's labeled somewhere on the board and you do not know what that label is, if you go to the GitHub page for the STM32 VCU, under hardware, under zombie, and then if you click on Zombieverter V1 BOM REL, should be an ODS file. That sounds like a lot. All that means BOM is bill of materials, but ODS is a file format for Excel. Don't worry, it's not some weird programming file. If I look under L4, L5, I can see that this is the DLP 11SA900HL, and this is an SMD4. For me, the first thing that pops up is DigiKey. Interesting. It says it's an obsolete part. This is a 2-line common mode choke surface mount, 90 ohms at 100 megahertz. The reason why I'm double checking this is I want to make sure it's not directional. If it is, I want to make sure I put it on there, in the correct way. According to this, it is not directional. So we should just be able to set it down and deal with it. So I found these tweezers that auto close very gently. I need to put these little chips here at L5, there at L4. To show you how small this is, I don't even know if you can see this, but there's 2 chips here. Incredibly small. And I'm worried that if it flies and disappears away, I will never find it. That's just a fact. So I'm going to open this very carefully. Tinning, just make sure I have a little bit of solder on the tip of the soldering iron. I'm going to take this chip. I'm sorry, I do not have a microscope for this. I'm going to place the chip right where I want it. Solder melting moved the chip. No. It soldered. Of course it soldered when it moved it. I'm just wasting footage at this point. So I just got it finished soldering. Oh my god. Was that the most difficult soldering job I think I've ever had to do. It ended up being that this hot rework station, it didn't get hot enough to melt that precise. Even with the soldering tip right there, it would either blow it out of the way. It didn't work quite right. So now we're gonna do a continuity test. Wow, okay. That tiny little chip right there, that one right there is what I soldered on. That's about the size of a penny. So you can kind of figure out how big that and that is. And I soldered that by hand. Okay, so after a suspense of waiting for my laptop to charge up, make sure that I'm not wiring this up wrong. Top right, permanent 12. Second is ground. Ground, 12 volts. Connect it to the ESP. Yep, showed right up. Something else different is probably happening. Okay, it's connected. Let's refresh. Nope, same error. Yeah, don't know, stumped. So last time you saw this, it still wasn't working. As I turned on continuity mode and I tested all the ground spots between what I touched, basically, one error. And that is that the little filters I put on, if you touch across for them, they should have continuity. So the first chip, L5, tested across it, both sides worked. I touched L4, the far side worked, the closer to me side did not. So I think when I was soldering it, even though, because it took so long of heating, cycling that little chip, I think I burned out half of it. At this point, it's 3 a.m. Not much more I can do tonight. So, got a new package. That's DigiKey, and that is for one of the 2 chokes that I soldered on. Let me remove the bridge that I added, remove that choke, put in a new one, and see if that fixes my issues. If not, I guess I'll be diving into forums. Well, let me check those pads to see if they still work. Better to check now. So all the pads are still good. So let's open up the new bag of stuff. So there are our little chips. I ordered 5 because they were like 46 cents each, and I figured I'd give myself a few attempts. If I, burnt out one and it was $5 of shipping, might as well get, a few more attempts out of it. The downside is also the reason why we had to hand solder this before. And that reason is the chip they were using before, apparently on DigiKey and Mouser, say they're discontinued. So I found their replacement part, which technically is even smaller. So it's the same package layout, just these are shorter than the old one. So that means it's going to be even harder for me to hold on to it with tweezers. Lucky me. Okay, good. So now all the touch pads on the chip go to the touch pads around it. Now it's time to test through the chip. Passed all of my tests. Turn this on. No, still issue. Communication problem between ESP and STM. I guess I'm gonna have to pause for today and just ask the people on the forum. So I had to go back to my apartment. But I brought the Zombieverter and some of these wire connectors and everything. Since I don't have one of these serial to USB converters, what I thought I'd do is I'd grab a Arduino Mega. I originally started with an Arduino Nano, but those only have one TX and RX line. The Mega has 3 of them. TX and RX, 1 are connected to the USB port on here, the other 2 are independent. So what I thought I would do is, since there's some kind of communication issue between the ESP and this board, I grabbed all of these jumpers, connected them to down here, here and connected them up to the board, and then I split off power and the RX and TX lines to this breadboard, connected all the grounds to each other. While the TX and RX lines from the ESP are connected straight to the board, I also have them connected to the Arduino Mega. And so what I thought I'd do is I wrote some simple code up here that basically just reads everything at the baud rate that I was told on the forum that everything's running at. Programmed this board to start reading it, booted up this stuff, got no messages. When I tried this with the Nano and I rebooted this, the Nano read something, but it was basically just garble and everything. I tried it at 7488 baud rate, and I was able to detect the bootloader that's running on the ESP, but that's not what we wanted. When I then changed it to the correct 115,200 baud rate, I was able to read something, but like I said, it was basically nothing. Wasn't reading it right. And after trying it with this and it just absolutely reading nothing, I went online and I started, trying to figure out why is it not picking up anything. But I found out that baud rate, just reading and printing the serial again, it's too fast for this board for some reason. The only real option I have here is to get one of these TTL serial converters, that way so we can read it over like a serial monitor here. We plug those in. Unfortunately, I can't fake it with an Arduino. I have to buy the real thing. Fortunately, it's only like $7, so it's not that bad of a price to hopefully diagnose this. So if you're in the same issue and you have parts like an Arduino, you have to have a board that is A, fast enough, and B, has enough serial ports on it. If it just has one, then that's most likely shared with its actual USB header. So yeah, I guess we'll wait for that to arrive. Oh yeah, and if you haven't programmed this board, then you're gonna need one of these ST links. It should be programmed, we just need to read what's actually happening between the both of them. Yeah, I don't really want to talk about that either, but I will. This is an 18-volt wall adapter for like an old CRT display. I'm at my apartment, so I'm scavenging what parts I have. Found this old buck converter, and that's set to 12 volts on it right now. And so that's being fed into the board. Through these long jumpers from the board is our ESP, and the reason why I did that is so I could connect the TX RX 3.3 volt and ground to this guy, which is one of the new boards that finally came in the mail. This is the FTDI. Basically what it's doing is it's converting the TX and RX pins into a USB to the computer. This board right here can only supply so much power. I think it's set like 90 milliamps, and I don't know if this requires more than that, but whatever. But I connected this 3.3 volt line to this guy, so that should be fine. That should have enough power. But you can see it's running. Right now it's connected to the app. You can see it still has that red bar, does not connect. And while I'm in this, we can see in PuTTY reading that serial connection. It's just that. It's just that. I know that's very entertaining to see. I mean, obviously you see this and you wonder why this is not working. Obviously I had it connected normally before and it wasn't working. And we've gotten to here to test it. I've tested this board independently. We got the original error message that I put onto the Openver forum. This boot mode 3,7. Now it's 3,6, which says it's a power delivery thing. It is connected over the right baud rate. I've tried both the 748080 and the 115,200 baud rates. And well, I mean, that's what I've been getting. And occasionally I'll get long sheets like this one where I'll just go through a bunch of times. And this is like the ESP cycling. And it never gets into Wi-Fi mode when it does this. And you can see right here it says this is boot mode 3,6. And it's always fatal exception. Load PuTTY back up. We can see that I got a bunch of that garble, and then it updates the web interface, whatever that is. So yeah, I don't know why this guy is not working like he's supposed to. Now it's doing it again. Did we just... Oh, let's see if we lost the app. Yeah, it's no longer refreshing. The loading symbol, I know you can't see, it's blurry, but now we can see that our ESP is doing this little thing where you see it flickers. Right there it goes. Boop. Boop. And every single time it does that, it makes that error message that you see that goes across there. Yep, there was one. Another. I don't know why. It's being fed 3.3 volt straight to it. It's getting power from the board. Oh, this board stopped. I'm going to reconnect the 12 volt line because I just unplugged it. Okay, well that's flashing again. That's reading data. That's doing its fun thing again. And that's just flickering. I don't know why. I've been doing that. Okay, I just clicked the on button here to feed it straight 3.3 volt straight to that on its own separate rail. Yeah, it stopped for a second, but now it's doing that again. I'm starting to think it's just a failed ESP module. So I plugged this black and red wires in, and that's going to the multimeter. And that's saying 3.12 volts. So I know that's a little bit low for the 3.3 volt line. Thought I'd give you guys an update. It is the next day. I've removed the WeMOS module. I've noticed some weirdnesses on it after measuring some resistance values. This 103 resistor down here is not reading 10k ohm, it's reading 5.5k ohms. This 100k ohm resistor is reading like 87, and I read in a forum post that that was too high. Don't really know about it, but this has been spitting out basically a lot of garbage, which is, you know, absolutely fantastic when we need something that's a little bit more precise. However, I got contacted back about my findings, and I got told to go back into the way that I had it to where only the number 2 was posted from the Zombieverter when on boot. And so I did that, and he told me to write JSON on the PuTTY interface and see what it records back. And when I did that, it spit out this, which looks like the parameter list for the Zombieverter. So that actually looks really good. So I think the Zombieverter is okay. It just, since this has been spitting out some weirdnesses, that's causing some issues. This has been a longer journey than I thought so far, but I messaged him back with this list and we'll see what we get back. Time skip, it's night now. I removed the previous setup. I've done some other tests and whatnot, but one that I thought was quite shocking is I tried to power this up using the 5 volt line and the ground from the Zombieverter and realized that this never turned on. Checked with it on the multimeter, find out that the ground line is actually connected to the rest of the board like usual. That 5 volt pin isn't connected to anything, so I was getting 0 volts from it. And so I was really confused. So I went around checking where the 5 volt line would be connected to that, and I couldn't find anywhere. So I pulled up this. This is the schematic diagram for the Zombieverter. And so I'm scrolling over to thinking on the right side here, these are like the headers and everything. Over here, that's where the old Wi-Fi module is, and if we look down, this is where the new module is. Notice how there's no pin headers here. This isn't the updated version, which I think is on his Patreon, which is fine. I just don't know where things go. And I can see here that the old header for the old Wi-Fi module, the only things connected is ground and the TX and RX. And then I realized when checking through all these pins, and I have this electrical taped off so I don't accidentally, touch anything by random, but when we peel it all the way off and I check for each of the pins, the only 4 pins are actually real pins. And that's this corner here, which is a 3.3 volt. The second pin in, which is ground, because the end one's 5 volt, but that doesn't exist. So that's not actually connected to anything. And then the TX and RX, which are the far pins over here. So yeah, only 4 of these are real, so the rest of them are just nothing. They're blank. That's good news, because that means that this thing is only supposed to run off of 3.3 volts, and that's why I was reading the weird voltage. I was reading 3.3 volts off of the 5 volt pin, and that's literally just because this doesn't do voltage conversion, and it wasn't getting 5 volts. So there's your reasoning. Why I'm here right now is that I was looking up more about the error code 3,7, and that's mainly either a power issue or it's a incorrect flash on this. I'm hoping it's that, and I finally just set up all the drivers. I think I'm going to do something super simple, like going under the 8266 and maybe blink. This should be dead simple. We'll blink the LED on it. So let's test that out real quick. See that we're still compiling. So it's connected. You can see that it is updating. Okay. Well, there we go. So now that I've erased the code that was on it, somehow I have to get that code back on there. And if I didn't already have it, I'd be completely screwed because there's no way to pull the code off of one to examine it, fix it, and put it back on. So let's go back and find where it's originally from. The OpenVerter community has done a lot of work, but it's kind of hard to find some of the stuff that you may need. So here's just a quick walkthrough of what you're going to need to do to reflash this pretty much every single step of the way. So let's start by going to the page for the Zombieverter. So I'm just going to type in Zombieverter wiki, and I'm going to hit enter. Usually it's the first one. You can read basically everything you need to know from here. There are more videos than these 4. They're just not here on the wiki. And if you need to get any of the code, there's a button right here. That's the GitHub page. This has all of the releases that you may need. We are on currently 2.17a, which is what my board is also on. If you need more than just this, you need the actual code, you can just press the name of the project, and it'll get you here, which is literally everything you may need for it. Now, we don't actually need this part, and you may be confused because we're working on the Zombieverter, we need the Wi-Fi code. It's not here, because it's technically a separate project, and it's made by a guy named Johannes, who's the person who's actually been helping us on the OpenVerter forum. So here's his page, and right here it says ESP 8266 web interface. Let's click that. This is the code you'll need for that. Yeah, it's in a little bit of a different spot. He has a lot of different ways of explaining how to get the modules and how to program them. A lot of it assumes you know how to do the basics of this stuff, which I have some of the knowledge of how to do that, but not all of the knowledge, unfortunately. We have our .ino file or ino file right there. So what I'm going to do is I'm going to click download zip from the code file, and so that just downloaded all of it. Let's minimize this real quick. Drag our master file right there. Let's click right here, extract all, and here's that file. Let's open that up and see here, web interface master. These are all the things that we actually need. Now, there's an issue with this, okay? You may think, oh, this is fine, we just click this. If I do that, the Arduino IDE is gonna work, but we have this issue. I'm gonna hit cancel, because I'm gonna explain how to fix this issue. It's really simple. It's because of how GitHub works. This is the master branch. So if we go back, we click this, and we erase the word master, and then that's it. You'll notice that the name of the folder is the name of the file. So now when we open it, no error, and things actually load correctly. And we have all of the subfolders and everything, because it's very important that we have this source folder that has the arm_debug. And trust me, you need that, because I tried to run this without it and I kept getting error after error after error. But it's right there. You just need to change the name of the actual folder. Now this is the code. You don't really need to understand it to upload it. All you have to know is that you go under Tools, Board, ESP8266, which is the type of board we're using. And then right here, we must D1, R2, and Mini. Now, if you don't have this ESP8266 option, that means that you don't have the boards downloaded. Now, how do you download them? You think, oh, I click on the board manager, and right here, I type in ESP8266. And you'll see right here, it pops up. But you won't see this. If you've never had it installed, it won't be here. But since I have it installed, it's here. If you do not have this here, it is not an option, then there is something very simple you'll need to do. What you'll need to do is, let's go back online, but there's another GitHub for the ESP8266, and this is very simple. You just Google Arduino ESP8266 GitHub, and it basically just links you straight here. What you need to do is you go down below, and you'll see it says enter this weird, and it looks like a website address. Let's copy that real quick. It'll say go to File, Preference, and Additional Boards Manager. That's right. The Arduino IDE doesn't actually include all of the boards. You have to manually tell it where to get it. So we go under Preferences, under File, and then right here under this Additional Boards Manager, we're going to hit paste, and that's going to be all of this right here. And then you're just going to click OK, and then it will load up all of your boards. From there, when you go under boards, you'll have this option for 8266. Same thing goes for if you're working with an ESP board. You have to do the same thing with these. Most of the regular Arduino stuff is already here. This is also another ESP library. These should be there by default usually. There's a GitHub page for basically every single type of board, but let's continue on to this. So now that we have the sketch and everything ready, there's actually one other thing we need to prepare, because the sketch here actually only allocates a part of the ESP's memory. The actual images and everything that's going to be displayed on the web interface are a different section of memory, and that has to be uploaded to the ESP. And the Arduino IDE doesn't actually have the ability to upload the SPIFs files normally, so we have to do a little bit of modification to it. And to do that, we need to go back to the Arduino ESP8266 page. And this is going to be a lengthy kind of description of how to get here. Everything's linked down below, but if you want to know exactly where it is, if you click under Dock, from here, go down to filesystem.rst, and you're going to get to this page. Down here, there is a uploading files to file system, and we're going to press right here to download this. Open that. We're going to see that we have this ESP8266FS file. Now, this is going to be a little bit weird to get to, but now we need to navigate on our computer where our Arduino save files are. For most people, it's under Documents, Arduino, and then here. In this doc, there's a full explanation of how to do this in case you need to fully read everything out, but you can see the home dir would be our documents file. We're under the Arduino file, and we're going to make a folder called Tools. So we're going to go New Folder, Tools. We're going to go back to the file that we downloaded, hit Extract. We're going to open this. We're going to see it's the same file name as before, and then inside there is the name Tool. Go back. We're going to click right-click and do Copy. Go back to here, go in Tools, right-click, paste. Now that seems really confusing, but if we open it all the way out, all the way down, what I want you to read is right here, okay? Documents, Arduino, Tools, ESP8266FS, Tool, in the name of this file, which is the same thing here, Arduino, Tools, ESP8266FS, Tool, and then the name of our jar file. So this is in the same directory as what you need. So now we can just close that, take our IDE, and we'll notice that under Tools, there should not be anything here. That's if this is already open. So what I'm going to do is I'm going to close this and reopen it. Go under Tools now, and if you don't see anything here, that's because I'm running the Windows 10 version of the Arduino IDE, that way so it stays updated, and I'm going to go down here and I'm going to click Install New Boards. Under Tools, it's still not there. Let's close and reopen. I notice that they still don't have a upload to ESP button up here. And if you have that issue, don't worry, I'm in the same boat. The solution I found, which is a very, very dumb solution, is the M1 version 2.3.3. I'm going to close this and I'm going to open up an older version of our Arduino IDE. Here is an older version. This is using 1.8.19. And under Tools now, we have ESP8266 Sketch Data Upload. I don't know why that doesn't show up with the Windows version. Probably because the file directory for documents Arduino is in a different location, while the non-Windows 10 version just uses the documents folder. I don't know, but it's very simple to find an older version of Arduino IDE just by going here, and then here it is, down here, Legacy IDE 1.8.19. Current version, down here, the older version. Don't know exactly why that matters sometimes, but now we can go over here, open. Okay, now we're back here. If you download all your boards on the other version, or you're just using this one, since in this version of the Arduino IDE, I don't have the ESP8266 downloaded. Let me do that real quick. All done. Close. Go back to Tools. Go under 8266. There it is. D1R2 Mini. So now we can go to the Tools, and we have our board selected. There's a few things I want to change right here. So first one is going to see is Erase Flash. Okay. Right now it's selected as only Sketch, and that's by default. What you want to do is click Sketch and Wi-Fi settings. Now the reason why is because later you'll see in the video, when I grabbed a brand new board, it had its own Wi-Fi name. That's because it's saved in a different partition of memory. So we want it to have brand new settings from this sketch. The next thing I want to do is go the flash size. I want to change this down here to the 1 megabyte OTA and 1000 kilobits. I don't know exactly why. It's just different memory partition sizes between how it's stored on the ESP. Just know it's the third option down. I didn't have luck with the first two, but this third one, when I clicked it, worked first try. You just want to do verify, just make sure everything you just did didn't change anything funky. Now it's compiled correctly, you want to plug in your board to your port like this, and then click Upload. Then right after it finished uploading successfully, go to Tools and press Upload Sketch Data. Click that. So let me explain this really simply real quick. There's two sides of memory for the ESP module. One side of memory gets from hitting Upload from the Sketch section, and that's what the code the board actually runs. Now any files that it needs that aren't from the Sketch here, it needs to pull from the other partition of memory. And the files it got from Upload Data came from here. That's why it's important when you're doing this, you only erase the dash master, because all of this stuff it's pulling from here. And on all of these files right here, this is aka data already from here. So that injected all into the ESP in the other side of memory. So now, after you've completed both tasks, your ESP will have both the sketch information and the downloaded data. 5, and I'm just gonna press Upload. And so unfortunately it doesn't detect if it already previously compiled, so it's going to compile once more, and then we're going to get into the loading process. Here it is writing it all in. We can see on the actual board that little light flickering on it. It's done uploading. So hopefully our WeMOS chip is actually successfully reprogrammed. As you can see, it's still plugged in. On the web version, it says that nothing's connected, but hey, we have the web version back. That wasn't there after we uploaded the Blink sketch, because remember that deletes all of this stuff, but it's back now since we re-uploaded it. So let's unplug that guy, put on the Zombieverter, and see how that affects this. Plugged it in, put 12 volts back on this. We have our blinking activity light back. This guy is on, so connected it back to the phone. It's refreshing, it still says web version 2.0, but as you can see, we still have the communication problem between ESP and STM. So flashing it didn't help, but hey, that ruled out one additional thing that we could do. Just for the sake of trying it out, I'm just gonna press the reset button. Do we still get that blue flash? We do. That disconnected me from the Wi-Fi. Let's reconnect that here. Refreshed, still have that issue. So now that I know it's only these 4 connections on here that actually do anything, I connected it up to this breadboard, just going to those same pins. And so now when I give this board 12 volts, that should supply power to both this and to the ESP, and that is powered separately. Because the TX and RX are actually where are supplying the 3.3 volt signal, and it needs a ground to connect to that. You don't actually need the power, these 2 boards with that one, with the 3.3 VCC line. So this guy right here has its TX and RX, and its ground line right now. Ooh, I did forget one. 3.3 volt line. So now when I plug in 12 volts to this guy, that should supply its 3.3 volt through that little chip right there, go through here, power that, and whatever data is being sent to this guy, we should pick it up with this because it's wired the same way that is. So let's give that a little bit of power. You can see that flickered once. I cleared the terminal, replugged it back in, and we got the, oh, well, that's new. Boot mode 3,4 unknown sequence. Well, you wouldn't believe it. I stuck a capacitor onto the positive and negative rail, just, to make sure that, power is smoother, because if we're having a power issue, might as well do that. So, I was getting those errors before, and then I typed Jason, and I got an error, and I typed Jason again, and it said, oh, here's the Zombieverter parameter list, which is what I was saying before when I was talking to the Zombieverter. But then I connected to it through the app, and as you can see, I have all of the parameters listed. You can see there's no red error at the top, so it's no, issue, and I actually got to be able to read that it changed the baud rate to 921,600. And then this is the loading bar that's currently going across right now, because I'm in the web interface, and I can operate it. I can select options, and I can change different inverters. There's the open inverter one, so when I change the stock Gen 2 Leaf inverter board over to the open inverter one, I can do it right there. But for now, we're working with Gen 1, which also works with Gen 2 and stuff. Yeah, it's not flaky at all. But the only thing that caused this to actually work was I typed in Jason. Maybe the ESP is not actually sending that signal correctly. Maybe it's sending it too early. Very odd. And try this again. Cleared the console. I plugged in power. That was a 2 a second ago. Just the number 2. Still nothing. Communication error. It's like 1:30 a.m. I think I'm done testing for tonight. But I think what I figured out is that this board, even when I have it in just my little test bed here and it's not connected to the Zombieverter, if I try and send it a message, it will not receive it at all. I can't get it to actually echo back what I'm sending it. So what I'm thinking is that out of the two TX and RX pins, T is for transmit, R is for receiver pin, I think the RX pin on this thing is super flaky for some reason. I'm going to try and get another board off of Amazon, pick up one of those, and see how that goes. So I'll get it, I'll flash it, and maybe it'll fix our issue. So after having a lot of chats on the Open Inverter forum, we have confirmed, maybe not confirmed, but definitely narrowed it down to the Zombieverter board is working fine. But this ESP board right here, he's doing something really funky, and we don't really know why that is. It could just be manufacturer something. It could be something broken on the inside of this. So I had to order some new ones. Thankfully they're cheap. One of the members of the Discord server noticed that I was having this issue and said that he bought a new board and he was working on and offered me one. Thank you very, very much for that, but I'm sorry, timing didn't really work out, and I got these ones. Board out right there. So what are the differences? Obviously the pin headers aren't soldered on yet. Chip is aligned the same way. The top down looks the exact same, except for this one actually says D1 Mini on it. On the opposite side, the layout is pretty much exactly identical. The resistor numbers look to be the same. That one chip that isn't on here doesn't even have solder pads on this one. Who knows about that? Before I put the headers on, I do want to upload the sketch to this and see if that actually takes it and everything, because if it does, then we're good to move forward. Let's grab our laptop. Uploading. Got our blue little flashing light. Done uploading. Let's see if we have our web server. Different name. There's no Wi-Fi connected to it, so yeah, I believe it's this board. It's called a Fairy Link for some reason, but I'm not going to question it. So the web server is there, but we don't have any of the files on it that this one did to do the visual interface. So somehow I have to get that on there. So it's been a second because after that last upload, it didn't have any visual interface. As you can see now, we have an interface. Why is that appearing now? Well, it's because there were some settings in the Arduino IDE that I hadn't changed. And I'm going to link a post on the Open Inverter forum that literally explains every step of how to do this. I'm going to link that. But anyway, now we have our interface. So I'm going to get the soldering iron out, solder up these pin headers, plug it into our Zombieverter, and see what happens. Good visual inspection. They look great. So now, let's get this guy plugged in there. Oh, makes me nervous. Get our positive and negative lines in here. So now when I flick the switch right now, everything's connected there correctly. 12 volts. Okay, got our activity light. We saw a little flash from our ESP module, which is fantastic. Now it's down to, can we connect to it? Oh, and by the way, the weird name from before from the ESP module, ever since I reflashed it, it is now the correct ESP and then the string name from the board. Connected. Oh, thank goodness. Do you see that word right there? Do you see those two massive words right there? No errors. I've been dealing with this for a month. Do you know how excited I am to see no errors? You know what that means now? I can go over to the parameters list. They're right there. Finally. Thank you to everybody who helped. Thank you for the community for actually listing full instructions on how to do this. Thank you for one of the biggest creators of the software to help me out on this. Oh my god. Thank you to a lot of people in getting to that step. Finding out that the original board, even though it looked fine and it was reading some of the messages fine, something wasn't right, and there it is. By the way, this was supposed to be a short video of me just soldering the components together, putting it on there, plugging in, and it working. It's 4 weeks later. This can happen to you. It might not. I certainly hope it won't. But this is the curse of my electronics. The first time I get something that should work, it doesn't. Until we buy another one. Find out it should have worked in the first place. But you know what? Who cares? Who cares? We're here. It's working. So if you had a problem that was similar to mine, I hope this helps you. If you have a new ESP module that you needed help on figuring out, I hope this video helped you. I hope that explained how to get through this whole stupid process. For the people who already know how to, I completely understand how easy it is to miss certain little points that a newcomer would get. Whole reason why the getting started chat on the OpenVerter forum is there. So let's get this sealed up into the box, reboot it, hope everything is still working, and go from there. Just making sure there's electrical tape on there. I have very little trust in a metal box. So that's all nice and screwed in now. Get our nice lid on there. Okay, now I am going to mention this. There is a gasket. It goes all the way around it. But notice, there's no gasket here. There is other kits on AliExpress for that. I don't currently have it. I don't plan on getting it. If you think that you have an issue with water or whatever area near this, which you shouldn't, but if you think you might, they do sell them online. I do not have the links for those. I am sorry, but I know they exist. So here are the screws. So there's our VCU. One box, all contained. Plug and ground, plug in 12 volts. Now we can't see the flashing lights anymore. Now we only know if this is actually on right now through if the Wi-Fi works. Okay, connecting to Wi-Fi. Connected. Let's refresh the web page. No errors. Oh, that felt like an eternity for a second. And now we have our full parameter list. This is fantastic. So now we can change it to, I want to use the Gen 1 Nissan Leaf, hit done. I'm just setting up what I want everything to run on. And there's a bunch of other settings we're going to have to get to in another video. But for now, thank all the people who've worked on this, all the people who've contributed to the physical board development, the software board development, everybody in the OpenVerter forums that have answered questions to other people, to my questions. Absolutely fantastic that community can come together and make something as cool as this. The next time you see this black box come out, we'll be setting up the wiring harness for the Leaf and everything. Regardless, thank you for watching. I hope this helped you. And if you're new to this stuff and you're just watching this video out of entertainment, I'm using this for the Ven Visceral project, which is my project name. We're basically taking apart a Nissan Leaf and reusing most of those parts and making an all-wheel drive electric go-kart. This just got a lot more exciting for me. Now we have significant progress in the electrical front.